Welcome to section 8.2. This is an extension of 8.1 and it's entitled Visualizing Data. And so our goal is to take the organization that we did last time by creating frequency tables and use that to create an actual visual picture of it. And so there's two main ways to do that that's talked about in the book. They actually talk about more than two, but your homework is centralized on two main ones, and that is the bar graph and the stem and leaf plot. So we're going to start with the bar graph. So the bar graph, I want you to know, is a very simple way to visualize a frequency distribution. So frequency distributions are what we did in the previous section. So our job is to visualize those, and it's very simple. You simply draw bars. Okay. And so what's going to happen is you're going to have a bar graph that's going to look something like this. The bars can be disjointed the way that our book does it, but it's going to look something like this depending upon the data. The height of it is going to be determined by the frequency, and down here will be the data points. And we'll draw bars to whatever height the frequency is for that count. And so essentially a bar graph is exactly what's shown here, bars that represent the height of the frequency for each of the items in the frequency table. And so I have an example here. In 8.1, the previous section, you worked to take categorical data and organize it in a frequency table as shown below. So you kind of remember this from our last video or from the homework that you did, where you have all these different majors shown. And what we did is we took all those different majors that were being given, undecided, biology, political science, and we organized them in a frequency table. And that frequency table summarized everything to say, hey, biology, there's 6 majors. Education, just 1. Political science, there's 3. Sociology, hey, I count 2. Undecided, there were 4 people that said they were undecided. So the only thing that 8.2 is doing is to focus on this frequency table. So I scrolled up for a reason. We have the raw data above the frequency table that's at the top of the screen. We take that raw data and we put it into a frequency distribution to be able to understand the size of each one of these, the impact that each one of them has. So we can clearly see that biology is the most popular major. So this one goes a little bit farther, may seem redundant to some, but we're going to draw a bar graph. And I want you to think about it as a simple way to see this data. So we're going to be drawing bars, and they're going to be at the height of whatever the frequency is. So we see frequencies from 1 to 6. 1, 2, 3, 4, 5, 6. Now, ideally, they're the same height or same distance in between. Doesn't look like I did a great job there, so don't stress. I don't model perfection. You don't have to use graph paper, but if you love to use graph paper, please do so. So then we're going to look at the very first major, which is biology, and we're going to draw a bar that represents biology, and we're going to go right up here to the 6 height, right? Because we knew that the biology was 6. And so I need to label this down here. So I would label it biology, right? So the data is down below. My next bar is going to be representing education, and it's going to be at a height of 1. So you do your work in pencil. So if you happen to draw it too high, you can erase and say, oh, you know what, that was a little too high. Let me make that just right up there at 1. And we would call this education. You're free to abbreviate whatever you'd like as long as it makes sense. Then our next one represents political science, and it should be at a height of 3. And so here I'll put poli-sci, as long as it's understandable. Sociology, right next to it, but double the height of the education one, and this is sociology. And then our last one is up at a height of 4. and we would label that as undecided. UND, whatever you'd like to do that, as long as it makes sense. Now, ideally, when you see this, the bars are perfectly the same size, going up to the right height, but this is what we call a bar graph, right? And so in the homework, you're going to be asked to make a bar graph, and sometimes that'll be off of categorical data, and they may give you the raw data and have you practice with 8.1, organize it in a frequency table. And then once that's done, then you're able to do the 8.2. So please note that, it's what bar graphs are is bar graphs are a visualization of a frequency distribution. So if you don't have that frequency distribution yet, you have to go get it. And once you do, then you're just drawing bars that height. And so you can do the same thing with quantitative data. So I have a cut and paste from the last video. I don't know if you remember this, but we, in a conflict resolution workshop, people were asked, hey, how many siblings do you have? And these were the responses. In our last video, we counted them, so I just copied that straight out. And so we have the data up above in the table. That's great. We use that table and we immediately do 8.1 and come up with the frequency distribution, right? The quantitative frequency distribution. Now our goal is to draw, the ask is to draw the bar graph. No problem. We know that we're going to have a x-axis and a y-axis, right? We know that the y-axis will be the frequencies. That looks terrible. Sorry about that. Let me fix that. And you could just put F for frequencies, but I'll write out frequency. There. Looks like we have a height of 10 that we have to achieve. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will be my height up there. And so one sibling is way up at 9. And we label that as one sibling. So we could put down here number of siblings, right? So we have it labeled. Here I didn't really have to do the labeling because the labeling was a description itself. But with just a 1 down there, it's kind of nice to know what it represents. In this case, the number of siblings. 2 is the same rectangle, just slightly taller. And so we would draw that right next to it, right? But there is a gap in between the way we do it. I've seen students just leave it like this, which is great. We could put a 10 there, that would be better. I've seen students put a little 9 here and a 10 here. Whatever your style is great. I can work with that. 3 is not as tall as 9 because it only goes up to 8 for 3 siblings. And 4 siblings, 1, 2, 3, 4, 5. I'm coming right across here. We'll say that's 5 siblings. Four siblings. It happens 5 times, and this is 8 times. You don't need to do those numbers across the top, but I just want to let you know of why I'm stopping there. 1, 2, 3, 4, 5. I'm trying to get to that level right there. As we go across, right here's my 8. And just doing the best I can, 9 and 10. Right, those dotted lines that I last did aren't necessary. I just want you to see what I'm trying to do. So I'll take those all out there. I don't want them to be part of the graph. So that's a large part of that first part where you do 1 through 13 odd. And so you're going to love those. Now, the even problems ask you to do a pie graph. I don't need you to do that, so I skipped that. I just want you to know the bar graph. And then there's a lot of questions that involve the stem and leaf plot. And it's really, really important that we talk about the stem and leaf plot because as we move on in the chapter, a lot of times when they give us data, they give it to us in a stem and leaf plot. And that's actually a very nice thing because what they're doing is they're organizing the data for us so that we can quickly get the answers. And you'll see that as we work in 8.3 and 8.4 and beyond. So they use the stem and leaf plot a lot. Let's talk about what it is. The stem and leaf plot, it actually groups data values in groups of 10. Now that is very generic. It could have a whole bunch of meanings. Here's what I mean. We're going to group it in the 10s, the 20s, the 30s, the 40s, the 50s, the 60s, and so on. And it can even, let me put ... 90s. It can even go to the hundreds, 110s. So you see what I'm doing, meaning by groups of 10s. And there's actually one, and that can keep going, but there's actually one before the 10s. It can be grouped into the zeros. Okay. And what it does, the stem and leaf plot says, okay, if you have data, you'll make these little stems, and the stems will be 0, 1, 2, 3, 4, 5, 6, 7. Let me stop there. Let's suppose we're looking at data, and the data has the value 15, 27, 35, 6, 72, 68. Let's suppose, and 62. And let me do another 24, 27, 13. Just making up stuff. So here's what a stem and leaf would do. They would say, okay, let's break off the tens digit, whatever that is, and we'll just write the numbers. So for example, my first number, I'll highlight here in yellow, is 15. So what I'm going to do with 15 is I'm going to come up here, and right next to the 1 that's there, I'm going to put the 5 to represent that 15. Then there is a 27. Okay, let me go into a highlighter here. We have a 27. And where's that going to go? In the 20s, and we'll put a 7. Then there's a 35. So I'll stop. So we go to that 35, and so I'll put a 5 there. Then there's a 6. Now the 6 has no tenths part, so the tenths part is 0, so it goes right up into the front. And we get 6, 72, 68, 62, 24, 27, 13. And we'll get a lot more practice with this, and you can back up the video. But again, what happened with 13? We went and put a 3 right there with the 1 out there. So we can actually see the data. You can see the data is 6, 15, 13, 27, 24, 27, if I keep going down. Okay. One other thing that they do, which is recommended for the future, is they put things in numerical order. So for example, right here, 15 and 13, the 5 and 3 portions are not in numerical order. They would go and erase those and put that line back in here, put the 3 first and the 5 second. Down here, they would say, oh, not 7, 4, 7. They would put 4, 7, 7. Now notice there's still 2 27s in here, right? Why are there 2 27s? Because there's 2 27s in the data values. We want them all, right? What's awesome is that you can see the values. You can see that there's 35. You can see that there's nothing in the 40s, nothing in the 50s. You want to leave it blank if there's nothing in those categories, meaning there was nothing in the 40s, nothing in the 50s. Do you see the problem with putting a 0? The numbers here don't represent frequency. If you put a 0 here, what that means is that 40 was a data value, but it wasn't. So we want to leave it blank if there's nothing in the 40s or the 50s. They'll go down here to the 60s and realize, hey, I want to put those in a different order. I need to put them from low to high, and they'll put a 2 here and an 8 here. And again, the value of putting them in numerical order, you will see later on. You don't have to do it. I would still give you full credit if you created a stem and leaf plot and didn't have them in numerical order. But they'll always give it to you in numerical order because they love you, right? You'll see its advantages in there. So again, let's just regroup here. What a stem and leaf plot does is it breaks off the tens and then has you write the data where it belongs so that you can see the data still and also start to get a picture of how it looks. There is a distribution here, right? That peaks, drops off, peaks again, you know, type of thing. You can see that picture if you were to turn it on its side. Okay, let's look at the first type of question they're going to ask. And this is an important question. The reason why they're asking this question is they want to make sure that you understand the stem and leaf plot. So let me see if I can drag this column out. It's not being listed. They have this column width as too little, but I'm not sure I know how to elongate that. So I apologize, it's not in a straight out line. Let's see if it allows me to do a column width. No, I don't see. Oh, maybe there, I can drag it out. Apologize, it's not letting me drag it out. So here's what the question is. How many data points are represented? What are the three lowest commutes? What are the three highest commutes? So why am I saying commutes? It says this up top. The stem and leaf plot below shows data collected from a sample of employed people who were asked how far in miles they commute each day. And so let's take a look at this and answer the questions in reverse. What is the full list of data? The biggest thing to understand here is, hey, what is the data? And so how is this being given? So what is this? Up here, there's this 4. What does that 4 represent? Well, that 4 represents the value, the commute of 4 miles. Let me get my pen back here for some reason. Don't have it. 4 miles is the first data point. Then somebody drives only 6 miles to work. Somebody commutes only 7 miles. Okay, so the next one is a 0, but nobody commuted 0 miles. Remember, the 0 here is in the 1 area, so that's the value of 10. Then there's another 10. Then there's another 10. Then there's a 12, a 12, a 12, a 14, a 15, an 18, and an 18. So all of these right here are the 0, 0, 0, 2, 2, 2, 4, 5, 8, 8 that are in the 1 area, right? If I break that out, there's a 1 area, a 2 area below it with 0, 5, 5, 5. These guys right here are represented right there. So hopefully you're seeing that. I think it's described really well in the book, but those are the next values that are there. Let's go to the 20s. Do we have any values in the 20s? Sure we do. We have 20 followed by 3 5s, so that's 25, 25, 25. In the 3 row, right, the one where we have the 3 there, that means we start out with 3 and we have 30, 30, 35, 35, 36. We have nothing in the 40s, but we do have a 50 and a 60. So those zeros with the 5 and 6 is not frequency, right? Those are the ending digits of data points. So here is the full list of data. How many data points are there? I don't know, we got to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 data values. That answers the first question. This list above is the last question. What are the 3 lowest commutes? The 3 lowest commutes, and let me come in here with the highlighter. The 3 lowest commutes are these 3. 4 miles, 6 miles, and 7 miles. What are the 3 highest commutes? I'll do that in blue. The 3 highest commutes are 36, 50, and 60 miles. Okay. That's how we read a stem and leaf plot. And you'll be given a lot of data in a stem and leaf form. And you're like, no problem. That's actually a great way to give it to us. And you'll see why having it in numerical order is very handy as you're asked different questions about the measurements of center. And you'll see that, I think, in the very next section. Okay, so that's a stem and leaf plot. What we also will be asked to do is to create a stem and leaf plot from data. So let's read this one as our last example. An entomologist is studying crickets recorded the number of times different crickets chirped in a 1 minute span. The raw data is as follows. And so we want to look at our data and we want to identify the lowest value and the highest value. So the lowest value I think I see is 82. I especially don't see anything in the 70s, right? I guess that's what I'm looking for. Because what a stem and leaf plot would do is say, okay, I see something in the 80s, I see something in the 90s, and even if I didn't, I would still need to write it because I see things in the tens, the hundreds, and I also see things in the 110s. Do you see anything in the 120s? I don't either. So these are our 4 leaves, right? Or 4 stems, I guess. Our 4 stems are the 80, 90, 100, and 110s. And now we just go. And my recommendation would be, hey, just write them out first. So I'm going to go data value by data value. 89. So a 9 goes there. For this data value right here, 89, we're writing, let's see if I can get rid of that. We're writing this 9 right here for that very first data value. Then we see 97, 82, right? Let me get rid of a mark here that's bothering me. 82. Then we see 102. That goes here. Then we see 84. Now you can get upset at me and say, you told us to put it in numerical order. You don't have to, but I'd recommend getting them in the right spaces first and then rearrange. That way you don't overlook anybody. 84, 99, 93, 103, 115, 105, 89, 109, 107, 89, 104, 82, 101, 109, 116, 103, 100, 91. Oops, look at where I put that 1. Put it in the 80s. Don't want the 1 in the 80s. That's why we do our math in pencil. 91 is right there. 85, 104. So you can see the shape of the data that the 100s rule out. I would totally take this as a correct answer. There's no need to rewrite it from low to high in terms of having the right answer. But it will be to your advantage at some point to have it in low to high for a couple of particular questions, specifically that when you're asked to find the median and when you're asked to find the mode. So you may want to take a second just to rewrite it and say, oh, okay, there's a 2, a 2, a 4, right? And so I go 2, 2, 4. Looking at that, there's a 5, followed by 3 9s. Okay. Then if I go to the 90s, the lowest is 91, 93, 97, 99. I'm trying to write them underneath each other so we can see which one's longer. Okay, we have another long one here. Looking at this, the lowest number I see, actually is 0. So there's a 0, 1, and just 1, 1. There's a 2 that I see here. There's a couple of 3s. So 3, 3. There's a 4, a 5. So a 4. 2 4s. Almost forgot a 4. 4. And then a 5. then a 7, and 2 9s. And then a 5 and a 6. Okay. What's nice about this is that you can see some stuff. You can see that 89 is the most frequent one. That's going to be a measurement of center that we identify. What happens most often? What's the data value that occurs most often? You can easily see it's 89. Up here, you could see that, oh, there's a bunch that tie, because I think up here it was groups of 3. So the repeated most often was 10, 12, 25, as all 3 of those are repeated 3 times. All right, as we look at that list, right, 3 25s, 3 12s, 3 10s, nothing else happening more than 3, nothing else happening exactly 3 times. And so you'll be able to see some things off of that with the data organized from low to high. But this is how we create a stem leaf plot. We break out the tens digits and then put in the units right here. And we can see, hey, cool, we've got a general shape here, right, that's coming out there, and gives us a picture of what's going on. But this is the answer right down here. Whoops. Let me back that up, and then we'll go back to the picture. This is the answer right down here, and this would also be accepted as an answer. It does not have to go from low to high. So hopefully this makes sense to you. We definitely be able to follow up with questions that you have, but I think this will suffice to help you get started and do quite well